And herewith I'll show the remaining parts of the similar triangle chapter number 14 in the grade 11. Before that, I'll complete this problem. You can see part 2 book, page 88, grade 11 mathematics. This diagram is there. They said BT equal to DC, OD equal to DR, everything described there. See, first question, show that or prove that BRCO is a parallelogram. BRCO is a parallelogram that you learn in the grade 10 maths. What is a parallelogram means? So many properties in a parallelogram. Opposite angles are equal. Diagonal bisects each other. Diagonal divide the area equally. Pair of opposite sides are equal and parallel. So many properties. Okay. So here BRCO. So I join this. BRCO. This is a parallelogram. BRCO is a parallelogram. Show that. Prove that. It's an interesting question. Think simple method. See, now this is a quadrilateral. In this quadrilateral, OR known as diagonal. Line joining the opposite vertices called diagonal. BC diagonal. See here, this equal to this data given. This equal to this data. So you learn grade 10 maths. In a quadrilateral, if diagonal bisects each other, the special name for that quadrilateral is parallelogram. That's all. So write first part answer. In quadrilateral, right? In quadrilateral, OBRC. Write that form. In quadrilateral OBRC, OD equal DR. OD equal DR. How you know? How we know that? Data. Data. What is next? BT equal to DC. BT equal to DC. Data. They said, they described in the problem. So this equal, the diagonal bisects each other. Now we can write below, right below. Therefore, in this quadrilateral, diagonal bisects each other. Therefore, in this quadrilateral, diagonal bisects each other. Therefore, this is a parallelogram. And finish it. That's all. This is a parallelogram, right? Diagonal bisects each other. Therefore, this is a parallelogram. This is not our syllabus. That means grade similar triangle. That's grade 10 work used here, right? Not today's lesson. That means equiangular or similar triangle. Not any application being formed here. Using your grade 10 idea, right? First part is over. So once you use parallelogram, once you shown the parallelogram, you can take the rest of the properties of the parallelogram. Especially what is a parallelogram? Opposite sides are parallel. Okay. Opposite sides are parallel. Parallelogram means opposite sides are parallel. Okay. Now second part. What is second part? Show that AQ is to QB. AQ is to QB equal AO is to OR. Second question, second part of that problem. For this diagram, prove that. Okay, what is that? AQ is to QB equal AO is to OR. How that idea? That's maybe our ratio theorem. In a triangle, collect a triangle and show the method of ratio theorem. Take this triangle, see this triangle, this panel and here parallel. See this triangle. If I write, see that part answer. Properly you decide which triangle is important to show this answer. Can I take this triangle ABR? See that? In triangle ABR. Okay, in triangle ABR, QO parallel to BR. It's all parallel, right? Because of parallelogram. The lines are straight. If you extend wherever, how many far so far, the lines are parallel. So take this triangle QO parallel to BR. QO parallel to BR. So if you want, you can write within brackets because of the parallelogram. Because OC parallel to BR, right? OC parallel to BR. OC means QO, QC, all the same straight line, right? Therefore, this parallel. So think only this triangle. What we learn in a triangle, line drawn parallel to another side. Divide the other two proportionally. Okay. Therefore, AQ is to QB. Therefore, AQ is to QB. AQ is to QB equal. What is that? AO is to OR, right? AO is to OR. That's the second part. Answer straight out. Once you show this parallelogram part, therefore it become like that. See, third part, QP parallel to BC. QP parallel to BC. That form, QP parallel to BC, you have to show that using this ratio theorem principle, right? Next, see, same method. Take this parallel, this and this. Take this triangle ACR, same method, we call similar or same. Look like this, right? Take this triangle ACR, OP parallel to CR, right? Therefore, AO is to OR equal to AP is to PC. So before go to this part answer, I come to just triangle. You can write in triangle ACR, OP parallel to RC, right? Or CR. OP parallel to CR. In a triangle, if a line parallel to another side, divide the other two proportionally, right? Therefore, AO is to OR. AO is to OR. What is equal to AP is to PC, right? AP is to PC. Can I say number 2, this one? Say this is number 1. The early answer say number 1, right? That is, we take number 2. See any arriving conclusion by combining the 1 and 2. AQ is to QB, AO is to OR. Here the same AO is to OR equal AP is to PC. Therefore, what? 1, 2 gives you what? Therefore, 1 and 2 combine, arriving a result. What is that? AQ is to QB. AQ is to QB. What is equal to what? AP is to PC. Okay. AQ is to QB equal AP is to PC. Okay. Important result for the last answer. See, I am raising is everything. Now see this triangle. Now see this triangle ABC. Think about the triangle ABC. With this answer, decide what happened here. AQ is to QB. equal AP is to PC. What happened? This PQ line divide the adjacent side proportionally. It's called converse theorem. Therefore, what happened? Lines are parallel. Therefore, in triangle ABC, PQ parallel to BC. Write that. Therefore, in triangle ABC, PQ or QP parallel to BC. A simple idea is we use to prove using the parallelogram. Opposite sides are parallel, hence take the ratio theorem for the other two parts. Last part is converse of the ratio theorem. That's the question. Okay, then we go to the main part. Our heading was what? Equiangular triangle. Still we not use that equiangular triangle means what? Samakoni trikona, equiangular. Samakona mukkonikal. Still we not use the angle here. And now I will show you the idea of this syllabus, equiangular triangle. So now write the heading, equiangular triangles. Write that, equiangular triangles. Equiangular triangle. Okay, so write this below, write this. If three angles of a triangle, are equal to three angles of another triangle, then that two triangles are known as equiangular, or similar. Another word we call similar or similar. That's the meaning, right? Triangle, for example, see this triangle, here a triangle. I say here 60, I say here 60, I say here 70, this is 70. So you know all three angle 180, therefore here 50. So here also 50. So what can you say? These two triangle, equiangular triangle, because angles are equal. Actually when we writing, I said triangle must equal, but later not necessary. Triangle not necessary, right? Two angles enough. Automatically third one becomes equal, because why? Triangle addition 180 degrees. Therefore, if you know two angle, remaining automatically equal. Therefore, later we use only two angles equal enough, right? Two angles equal pair of triangle, not only two, any number of triangle, two angles are same, then they are similar, they are equiangular, right? This is the basic numerical value I have shown. These two triangles similar. There's an important property of this equiangular triangle, right below. In a pair of equiangular triangles, corresponding sides are proportionally equal. Corresponding sides are proportional. Right? Corresponding sides are proportional. Okay. And the important part we will use in the question later. Now I will show you clearly how to prove the equiangular ideas and what the result below. See this. So draw two triangles, separate two triangles. Draw this. It's a triangle ABC. And another one, triangle PQR. It's two triangle, right? I say the angle A equal to R. This particular problem is a data. That is data, right? I take this angle equal to that. And angle B, I take angle to this. Okay. Also remaining, draw this figure. See this triangle, angles are equal, right? Angles are equal. Therefore, these two pair of triangle, not concurrent. There is no angle case congruency. Side, 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 or side, angle, side, or angle, side, or hypotenuse side, or angle, side. There is no congruency case for angle. Okay, right. Now, see, I show the method how to write the equiangular case, right? So in triangle ABC, comma, triangle PQR, in triangle ABC, comma, triangle PQR, angle A, I take a single letter I show, angle A equal to what? R. Angle A equal to R. That's called data. Particular problem that is provided, say data, right? Next word, angle B equal to what? Here comes this one, angle P. Also given for particular problem, say data. At last, angle C equal to angle Q, data. Okay, angles are equal. Later we won't take 3 angles, 2 angles are enough. So angle. Therefore, right below, therefore, triangle ABC equiangular to triangle what? PQR. Triangle ABC equiangular to triangle PQR. You don't know how to write these statements, right? You know this 3 line called congruency. Like we have symbol for equiangular also. That's not most necessary, but you know that. That is triangle ABC, symbol like this symbol, right? Triangle PQR, triangle ABC, write this symbol. That's called equiangular notation like this. Okay, therefore, now we have come to the main part of the equiangular. Corresponding sides are proportional. You have 2 triangles said to be equiangular. Corresponding sides are proportional. See, what do you mean? What do you mean corresponding side? Opposite of the same angle. See, therefore, this angle A, but the corresponding side BC over this angle equal to this angle, opposite side PQ, right? PQ equal, take another angle here, I take the angle P, opposite AC, over this angle equal to this angle, opposite PQ. And this angle AC, here this one, what? QR, right? QR. At last, what? Take this angle, opposite side is AB, over this angle equal to this, opposite side is PR. It's a very important result. This is the meaning we call sides are proportional, right? Corresponding sides are proportional if the triangles are equiangular. So here, how many equations available in this case? This equal to this, one equation. This equal to that, another equation. Also, first and the last, three equations available, right? So what is the question? Our exam problem, our book question says, they will give BC 5 centimeter, PQ is X, AC 7 centimeter, QR is Y, here 3, here 5. So find the values of X and Y like that. The problem I will show how to work. This is the very first way, what do you mean the equiangular triangles and how to show this proving method, and finally result corresponding sides are proportional, right? Okay. See, for another diagram, I am showing now all the future diagrams how to use this equiangular idea. See another diagram. I take a triangle ABC. Here is a PQ. These two parallel. Draw that diagram. Next theory, I will show next my method. Draw this diagram, triangle ABC and PQ parallel to BC. What are the results we can collect from this diagram? Okay, see, in triangle ABC, PQ parallel to BC. Therefore what? Let's we learn many last videos. In a triangle, if a line drawn parallel to a side, divide the other two proportionally. You have got that? AP over PB equal to what? AQ over QC. Let's finish. We work many questions. This I say results one, number one. That is number one, right? Now come this here. How many triangles available? Small triangle APQ and the biggest ABC, right? Here there are two triangles available. How these two triangles? If I mark the angles here, the lines are parallel. Therefore, this angle equal to this. Why? Why these two angles are equal? What I mean? Corresponding angle, because of lines are parallel. Okay. Also, this angle equal to this angle, corresponding angle. What about this angle? Angle at the vertex, say how that? Small triangle, you have that angle. Large triangle, we have that. Therefore, that angle known as a common angle. You know, in congruency question, we use some common side problems, Podupada. Like that here, common angle available. So anyhow, see this, small triangle, three angles, large triangle, three angles equal. Therefore, small triangle and large triangles are what? Equiangular triangles. Okay. So I show next case for this diagram. In triangle APQ, write this, triangle APQ, comma, triangle ABC, okay, take the small triangle and the largest triangle, okay. Now I show the equiangular properties. I take this angle, APQ angle equal to what? Small triangle, this angle equal to largest triangle, this one, ABC, right? ABC. Corresponding angle. Reason corresponding angle, right? And come here, AQP, right? AQP angle equal to what? Large triangle, this angle, ACB, right? ACB. Right, same reason, right? Corresponding angle. Why they are corresponding? Lines are parallel, okay? This is enough. Two angles actually enough to show the equiangular. But I show the third one also. Come this one. What the name? PAQ. PAQ triangle. The large triangle, what the name? BAC, okay? BAC. What the reason? Common angle. Podu kona. Common angle. Podu kone. Okay. That's all. Common angle. Copy that common angle. Therefore, triangle APQ. This symbol, right? ABC. These two triangle equiangular. Therefore, very important diagram. You can use the ratio theorem here as well as also this equiangular triangle. Okay. So what happened after two triangles said to be equiangular? Their corresponding sides are proportional. As I shown this for the previous diagram. And now we write that pattern. I take this angle, take the common angle, small triangle first. Small side PQ over what? Larger side BC. Okay, next I take this P angle, opposite side AQ over, what is over? What? Over? Over this angle AC. Small angle P opposite side AQ. This angle equal to this opposite AC. Don't say QC. QC not a side of a triangle. Large triangle AC. Equal at last. Take the angle Q opposite small side AP over what? This angle equal to this opposite AB. AB, right? AB. Say results to very important today. This video very useful to work all the remaining questions, past paper problems, this book works and some of the model papers. So such a triangle we can take a two results, ratio theorem and the equiangular theorem. Okay, this way. So here very important, don't miss the order. If you take the small triangle first, all the numerators are small triangle from the small triangle. Denominators are large triangle. Otherwise you can change it. You can write all up numerator from the large triangle, then here small triangle side. If it's large triangle, here small triangle, here large triangle, that is wrong. Very important. The students makes error, wrong way. They use these questions. They misuse the idea. The triangle sides are they shuffled. The numerator takes from which triangle, same order, write the denominator. So very important, results 1, results 2, ratio theorem and corresponding sides are proportional idea. Next video I will show some more problems.